Find the most relevant document with cosine similarity in Python. By the end, you will rank short documents by relevance, swap raw counts for TF-IDF to improve results, and rack the logic into a tiny search function you can reuse. I'm Professor Pi, teaching search and information retrieval from basics to advanced in simple Python. Cosine similarity, which measures the angle between two vectors, captures how similar two texts are, while ignoring document length. It optimizes direction matching, so two documents that use the same words end up close even if one is longer. The trade-off is memory and time for dense vectors and exact comparison. For small collections, you get instant, accurate rankings. For larger collections, you will consider approximate neighbors or an index to keep latency low. It is excellent when you want semantic overlap fast and interpretable. Cosine similarity shines for near duplicate detection, query ranking, and quick prototyping. It struggles when term frequency alone misses phrase meaning, or when vocabulary is huge. We will build a tiny search pipeline that ranks a small corpus for a query and shows top matches. Now we will compute raw counts between two short documents and get their cosine similarity. This snippet computes cosine similarity between two tiny documents using raw word counts. It builds a simple vocabulary from the two sentences, counts how often each word appears, and turns each document into a vector of raw counts. Then it computes the cosine measure between those two vectors, which tells us how aligned their word usage is, independent of length. This is a great first step to see how cosine works with plain counts. If you add more documents, the vocabulary grows and vectors get longer, which increases memory and CPU for pairwise comparisons, but keeps the logic easy to follow. Next, we will package similarity into a reusable function and compare one document to a small set. This snippet builds a reusable cosine function and compares one document to the set. It converts every document into the same count space, applies the cosine computation between the query vector and each document vector, and returns a score for each match. The function isolates vectorization and similarity so you can reuse it across many queries. If the snippet exposes a normalization option, changing it will shift whether document length matters. Turning normalization off makes raw frequency matter more, while turning it on focuses purely on direction and tends to improve fairness across short and long documents. Next, we will rank the corpus for a single query and inspect the top matches. This snippet ranks documents for a query by cosine similarity and shows the top results. It runs the reusable function across the corpus, sorts scores, and prints the highest scoring documents with their similarity values. This is the moment you see what words and patterns drive relevance. The snippet usually exposes a top number parameter that controls how many results you return. Increasing that number gives more candidates but may include weaker matches. Decreasing it gives a concise list for immediate inspection. Use this to judge whether raw counts capture the relevance you expect before changing weighting. Next, we will apply TF-IDF weighting and rerun the same query to see clearer relevance. This snippet applies TF-IDF weighting and re-ranks the same query for clearer relevance. TF-IDF, which weights terms by how common they are across documents and by their frequency inside a document, downplays stop words and boosts distinctive terms. The snippet replaces raw counts with TF-IDF scores, then recomputes cosine similarity. You will often see more meaningful top hits because rare but informative words gain importance. If the snippet exposes n-gram or smoothing parameters, expanding n-gram range helps phrase matching but increases dimensionality and memory. Tweak those to trade recall and precision. Next, we will wrap the whole flow into a tiny search function that returns the top matches for any query. This snippet wraps retrieval into a tiny search function that returns top K documents. It encapsulates vectorization, optional TF-IDF transformation, the cosine scoring loop, and result slicing. The function takes a query string and a parameter for how many top hits to return, so you can balance verbosity and speed. For speed, you can pre-compute and cache the document vectors, so each query only needs the query vector and the scoring step. If you change the caching or pre-computation strategy, you trade memory for query latency, which is important for frequent queries. Recap: Cosine Similarity measures angular closeness of text vectors and ignores length. Use it when shared word usage signals relevance and you need an interpretable, fast ranking. One caveat: raw counts can mislead. TF-IDF or better features are often necessary for clear relevance. Next step: tune TF-IDF n-gram range for your corpus. Then rerun rankings and measure precision at top 5 to see what improves. That single change often yields the biggest practical boost. If practical IR that actually finds relevant documents helps your projects, subscribe and watch the rest of the information retrieval series.